Okay, so back to multiplying polynomials together. What if it's not a binomial times a binomial? What if it's a different type of nomial set that we have, such as this one, a binomial times a trinomial? Well, the idea of FOIL or box method could still work for both of these, okay? But really what's going on is we're taking one of the items and we are multiplying it out as many times as we need to give it to each term inside of the other polynomial. So I kind of rewrote that down here for you so you can see that in action. It's an x times each thing inside of that polynomial. Then we could take the other part of our first polynomial and give it to each term in the next one. And so then we could write it as I did down here for this part. So there's going to be 6 multiplications total because it's a binomial times a trinomial, 2 things times 3 things. It's going to have 6 parts altogether. So when I go ahead and do the first one, I'm going to end up with x times x squared, which is x cubed, x times 2x, which is 2x squared, x times 4, which is 4x. Then I move down to the next one. When I do 3 times x squared, I get a like term. Since I kind of have this written vertically, I'm just going to line them up as well. So 3 times x squared is 3x squared. 3 times 2x, 6x, another like term for me to line up with. And then 3 times 4, positive 12. So I write that one down as well. And you can see that if I line these up and combine my like terms, I'm going to end up with a 4-term polynomial. So this would end up being x to the third plus 5x squared plus 10x plus 12 as my final answer. And you can see I wrote a little note here that you can still use the grid method for this. It's just you would need it to be 2 by 3 instead. So you might put the x plus 3 on one of the sides and the x squared plus 2x plus 4 on the top. And you can still get the 6 multiplications. It's just they'd be the same numbers as here, but in the boxes. So why don't I show you that with this next one? So I'm going to go ahead and make a 3 by 2 because I have a binomial times a trinomial. I have an x plus 2 being multiplied with an x squared minus 2x plus 1. So an x times an x squared is x cubed. An x times a negative 2x is negative 2x squared. And x times a 1 is an x. A 2 times an x squared is 2x squared. A 2 times a negative 2x is negative 4x. And a 2 times a 1 is 2. And if you look at these boxes, 2 of them match up, and another 2 match up. Sorry, I hit my rig, so sorry about that noise in the middle of that. And I have one item that's a third power, then I have 2 items that are x squareds, 2 items that are x to the firsts, and a lonely constant. So that means if I put all of these together, I'm going to have a 4-term polynomial again. I have x cubed. Oh, no I don't, because 2 minus 2 is 0. These canceled out. So don't forget, even if you do see a certain number of terms when you try to look at your like terms, some of them can go away. That's 0x squared. There are no x squareds anymore. A negative 4 plus a 1 gives us negative 3x when I try to combine those like terms, so that one didn't go away. And a 2. So while I did the first example with you, and I ended up with a 4-term polynomial, here, because something canceled out in the problem, I only end up with a trinomial. So that can happen sometimes. All right, let's just go back to distributive method for this one. All right, so if I distribute, I'm going to get 6 terms total. X times x squared is x cubed. X times negative xy is going to be a 1 times a negative 1, so that becomes negative 1. The x times x becomes x squared, and we only had the 1y. So x squared y is being subtracted. And x times a positive y squared, they just get written next to each other since they can't get put together. All right, Moving on to the negative y now being distributed. A negative y times x squared. Well, that's just going to be the x squared and the y written next to each other again. And a negative times a positive is a negative. So notice I'm lining them up again vertically for those of you that like that vertical method. Then I have a negative times a negative, so that's going to be a positive. An x, I only have one of them. And a y times a y, so that's y squared. And then negative times a positive is a negative, and y times y squared is y cubed. So I have like terms lined up vertically again. You didn't have to do it vertically. You could have written this as one giant horizontal line of phrases, but that's okay. Either way, this is going to have an x cubed. The two negative ones combine to be negative 2 for a new coefficient for x squared y. The two positive ones become positive 2 when you combine like terms for xy squared. And we only had 1 minus y cubed. Okay? Now, some of you might notice that this is a degree 3, a degree 3, a degree 3, a degree 3. They all tied. Okay? So I tried to tell you and remind you that we have a alphabetical order that we try to go in, but when the letters mix or match, we try to favor the x's as much as we can because they come alphabetically first, and then the y's are kind of trailing behind. So that's why I have this in this structure. If you put them mixed and matched, as long as the signs were correct, like this was still a negative 2, and this was still a positive 2, and this was still a negative 1, and you had them in a different order, I'd still give you credit. And if you have any questions about what I mean about that, you can ask me when I see you tomorrow. All right, we're on to our last set of practice problems, okay? Again, if you feel like trying some of these on your own, you can practice them and then come back to the video, resume the video after you've paused it. That might be a good idea, but I'm gonna jump in and show the answers and show my process for these. So, and by the way, I don't expect everyone to finish the videos today. So if you're up to a point and you're like, oh, the period's almost over, remember, I always have these extra practice problems inside of our daily activities anyway. So I don't necessarily expect everyone to finish going through these. That's okay. So x times x squared is x cubed. X times x, or x times 1x, is 1x squared. X times 2 is 2x. Then I move on to the plus 1 to distribute that, the positive 1. 1 times x squared is x squared. 1 times 1x is 1x. And 1 times 2 is 2. So I have 4 terms that combine together to be x cubed plus 2x squared plus 3x plus 2 as my final answer. All right, looking at question 2. Same thing. Triple distribute the x and triple distribute the negative 2. So x times x squared is x cubed. X times negative 2x is negative 2x squared. X times the 3 is 3x, positive 3x. Negative 2 times x squared is negative 2x squared. Negative 2 times negative 2x is now positive 4x. And negative 2 times 3 is negative 6. So when I combine like terms that I lined up vertically here, I get x cubed minus 4x squared plus 7x minus 6. Final answer. All right, next one. X times x squared is x cubed. X times 4x is 4x squared. X times negative 1 is negative 1x. 4 times x squared is 4x squared, positive. 4 times 4x is positive 16x. And 4 times negative 1 is going to be negative 4. So I have an x cubed. 4x plus 4x is 8x. Sorry, 4x squared plus 4x squared is 8x squared. Negative 1x plus 16x is positive 15x. And we have the negative 4. So there's our final answer for that one. All right, question number 4. M times m is m cubed. Sorry, m times m squared is m cubed. M times m is m squared. M times 2 is 2m. 5 times m squared is 5m squared. 5 times m is positive 5m. 5 times 2 is positive 10. Combining our like terms, that gives us m cubed plus 6m squared plus 7m plus 10. Final answer, polynomial. All right, just to show you for question number 5, okay, the binomial in front is written not in standard form, not in decreasing order. That doesn't matter. Just go ahead like everything like normal, but then I might restructure it at the end so it's in our standard form. It doesn't really matter, okay? So 2 times y squared is 2y squared. 2 times 3y is positive 6y. 2 times negative 6 is negative 12. Y times y squared is y cubed. Notice I wrote that more to the left because it's not lined up with these. Okay, y times 3y is positive 3y squared. Y times negative 6 is negative 6y. So I structured it vertically so they're lining up again. If you had just written them as all one line, the y squared would have appeared before the y cubed and they would have been out of order, just so that you're aware. But when I do the vertical method here, I can see that I have a y cubed. These combine like terms to become 5y squared. These become 0y. The y's are gone. There are no more y's because they canceled each other out. And we had the minus 12. So a trinomial final answer. And our last one. C times c cubed is c to the 4th. C times 3c squared is positive 3c to the 3rd. C times negative 4c is negative 4c squared. Negative 2 times c cubed is negative 2c cubed. Negative 2 times 3c squared is negative 6c squared. And negative 2 times negative 4c is positive 8c. Combining like terms, we get c to the 4th plus 1c cubed minus 10c squared plus 8c as our final polynomial. All right, that's it for today. Your homework, as long as I did everything right, should be posted by the time you finish this video. All right, I will see everyone tomorrow.